Hello everyone. In this video I'll be talking about section 4.5. This is where we're going to be using what's called a matrix to solve systems of linear equations. We've talked about a few different ways to solve these already. We started with graphing and explained that it's not the best way. If you don't have a perfect graph, it's going to be tough to tell the solution. We also talked about substitution, which is more algebraic, right? You plug one equation basically into the other. We also talked about elimination, also known as the addition method. This matrix approach, and I'll talk about this in detail, mimics more the elimination / addition approach than any of the others. It's basically elimination, and it's actually technically called Gaussian elimination, named after someone named Gauss. And it's just a way of structuring the work. There are a few allowed moves that you can do to accomplish the goal, and those allowed moves are right here. I want to first talk about what the goal is and why the goal is the way it is. So you're going to be faced with a system of linear equations, maybe like this system of linear equations here. And what you're going to do is you're going to set up a matrix. And I'll actually set this matrix up right here. So what we do to set up the matrix is I look at the coefficients on the variables. First off, I have all my things organized, meaning x's are above x's, y's are above y's, and we have pure numbers above pure numbers. So what I actually do is we pluck off these coefficients. So -1, I'm going to take that -1. There's assumed to be a -1 right here because of that negative symbol. So I'm writing that -1 there. Then I have a 5. What we do to represent the equal sign is we kind of write these dots. So just a dotted line. And then on the other side of that, I'll write this 4. So that's this first equation written as row 1. So we'll refer to this as row 1. And then in the next one, I'll have a 3, a -1, and a 6. So what we're going to do, this is called the augmented matrix, by the way. So just this thing that I wrote down, that's called the augmented matrix. And what we want to do is transform this thing using these allowed moves. So I'm calling those allowed moves, but they're officially called row equivalent operations. So allowed moves, and what we want to do after those allowed moves have been carried out is we want to look at something that looks like this. This is our what's called an identity matrix, and it's our solution matrix, and we're going to have some number here, some number here. So I'm just writing those number symbols, but it'll be just some number. So this is our goal right here. So we want to start here, and we want to work our way to this type of matrix where we have a 1, a 0, a 0, a 1, and then these numbers over here are actually the solutions. So why is this the goal? Well, now imagine going back to the equation. So let's, from the matrix, write the equations. And a little bit ago we wrote from the equations, we wrote the matrix, but we can go back and forth, right? I can just write the equations from this matrix again. So if the matrix is in this form, what would the equations be? We would have 1 times x, right? That 1 means it's a coefficient on x, plus 0 times y, that's the coefficient on y, and this would all equal number 1, whatever number is sitting here. The second row would lead to 0x, right? That 0 is a coefficient on x, plus 1y equals number 2. Simplify this. So 1 times x, that's just the same as x. 0 times y, that's just the same as 0, so I won't write anything. So this would tell us that x equals number 1. So actually, when our goal is this way, this is actually our goal's way of telling us what x is, right here. Right? So from the first row, we actually don't have any more y's, that's why that 0's there, and we just have 1x equals number 1. So this would tell us that this is the x component of our solution. Right? If you look at the second equation implied by row 2, 0x just means there's nothing there. Plus 1 times y just means we have a y. And y would just be equal to number 2. Right? And we would have our solution then. So that's why this is our goal, is because really this is just our matrix way of writing our solutions. Okay, so now to actually try one. So I'm going to rewrite this augmented matrix over here. So we have, again, -1, 5, and 4. And then I'm writing the second row of the matrix from this second equation, 3, -1, and 6. So here's the pattern. What we want to first make is this 1. So we want to first make that a 1. What are we allowed to do? So here are the things we're allowed to do. Sorry, let me move that down. So here are the things we're allowed to do. We're allowed to interchange any 2 rows. What that means is I can decide, you know what? I would rather row 1 be written right here as row 2. So I'm allowed, instead of writing the first equation first, I can write the first equation second. Or I cannot do that, right? So you're allowed to do this. It doesn't mean you need to do this. So you're allowed to interchange any 2 rows. And as many times as you want, right? You're allowed to do all these allowed moves as much as you want. Okay, so interchanging rows, that's actually not going to help me make this 1 at the moment. Okay, so I'm not going to do that. But the second option says we can multiply all elements of a row by a non-zero constant. Remember, with the elimination process, we were allowed to multiply by a non-zero number and then add, right? And that's essentially what this thing is also saying. So I'm allowed, if I wanted to, and I don't know that I want to, but I'm allowed to multiply the first row by 17. I'm allowed to multiply the second row by -1/2. I'm allowed to multiply the second row by 100 million. It doesn't actually matter what you multiply these by. You just can't multiply by 0. So in order to make this -1 a positive 1, because that's what our goal requires, I'm going to make a move. And actually, I just need part B here. So what I'll say is I'll say negative row 1. This is my notation telling me that what I'm going to do is to multiply row 1. So this is my name for row 1, R sub 1 here. I'm going to multiply row 1 by -1. So when I do that, I get, well, -1 times -1 would be +1. -1 times 5 is -5, and -1 times 4 is -4. I have done nothing to row 2, so I'll just write it down. Okay. So that's an important first step. We just accomplished the first part of the goal, right? We have a 1 here. What you then want to do is create the 0 below it. So that's kind of the pattern, is we create the 1 in any particular column, and then we create the 0 or zeros below and or above it. Okay, so what I'm now going to focus on is changing this 3 into a 0. And I need to do that by sticking within these allowed moves. So this third one says you can replace a row with the sum of that row and a multiple of another row. Put it more simply, I'm allowed to multiply this row by a number, and then I'm allowed to add that result to this row. So I can multiply row 1 by like 2. And then I'm even allowed to add that result down, right? We're allowed to add equations to one another. That's like the elimination method also. So the way of notating this, well, I have a 1. I'm allowed to multiply row 1 by any number. Okay? I would actually prefer if that 1 were a -3. That way, when I add these equations together, I get my -3 plus 3 is 0. So I'm actually going to take now -3 times row 1. And I'm just notating that again. I recommend notating these things so that when you make a mistake, and it just will happen, you're gonna make a mistake, and that's okay. But if you notate that, you'll at least be able to go back and try to catch your mistake a little more easily. So let me go ahead and do this. So over here, I'll write -3, +15. Why +15? Because I'm multiplying row 1 by -3. -3 times -4, we have a +12 now. Okay, so let me rewrite the second row. I didn't do anything there. So here we are, we have these 2 rows. I just multiplied all the elements of row 1 by a non-zero constant. What I'm allowed to do then is I'm allowed to add row 1 to row 2. So replace a row with a sum of rows. So what I'll do is, for my notation, I'll say row 1 plus row 2 equals new row 2. Okay. So over here, row 1 plus row 2 equals new row 2. What that means is row 1 is not changing. I'll just write row 1 down. We're just using row 1 to affect row 2. So now I'll actually add. So when I add down, I get my 0, -3 plus 3. So that 0 goes here. 15 plus -1 would be 14. 12 plus 6, 18. Okay? So we just accomplished this 0 right here. But we unaccomplished, we got rid of our prior accomplishment. Right? I no longer have that 1 there. I now have this -3, and that's not what we want. You know, that's not what the goal is. But that's okay. We can always actually fix that. So I'm allowed to multiply all elements by a non-zero number. So what I'll do is I'll multiply -1/3 times row 1. Right? -1/3 of -3 is 1. So -1/3 times row 1, we get our +1 back, right? -1/3 times -3, that's +1. -1/3 times 15, that's -5. Right? -1/3 times +12, that's -4. And then I'll just rewrite this. So now we're good again, right? We've kind of recovered that original accomplishment. And column 1, right? All of column 1 is complete now, right? We have our 1 and our 0. And that's really what you do. You work on columns. You complete the column, and then you move to the next column. So that's the pattern that you're going to work in. So after you complete this first column, you then move to the second column. And actually the first thing you want to do is focus on making that a 1. You actually don't want to start up here. You actually want to start always by making the 1 in a column. That way you can make the zeros off of it. Okay, so all that, I'm saying all that to say, now I'm focusing on this number here, this 14. I want to first make this a 1. That's the next move in this kind of flow. How can I make that a 1? And also, how can I make that a 1 without screwing up the first column? Right? We don't want to make this a 1 and then make that a 2, because that'll undo this previous part of our goal. So maybe after some thinking, 1/14 times row 2, right? That's a simple way. If I multiply row 2 by 1/14, I'm still going to have my 0, and the 1/14 times the 14 gives us our 1, and yeah, we're going to have a strange number here, 18/14, but that's okay. So I'll just write down this first equation again. Nothing has changed there. So 1/14 times 0 is 0. 1/14 times 14, that's our 1 that we wanted. And 1/14 of 18, feel free to use the calculator, of course. So 1/14 times 18, 9/7 in reduced form. All right, so I just accomplished that part of the goal, right? What you always do is after you make the 1, you want to pivot off of that 1 and make the 0 above it. Okay, so now I'm going to think about, okay, how do I use this 1 to make my 0 here? And again, of course, simultaneously considering that I don't want to screw up the previous accomplishments, right? So I want to make progress without going backwards at all. So I want to make this a 0. So what I will do is 5 times row 2. Right, I already have a 1 there, so 5 times row 2, I'll still have my 0, and then I'll have a 5 here. That 5, when that 5 gets added up, I'll get my 0. When that 0 gets added up, I'll still have my 1, and everything's all good. So 5 times row 2 plus row 1 equals new row 1. Right? So this is what I'm going to do next. I'm using another kind of part C, basically. I'm kind of doing a mixture of part B and C here in this step, right? I'm multiplying by a non-zero number, and then I'm adding that to a already existing row, thus creating a new row. We did this before also, right? So here, I kind of did it in parts, but really I could have, instead of going back and forth, notice how I used a -3 times row 1, and then I just undid that by doing -1/3 row 1. An option, and what I kind of recommend really, is writing these numbers down. So 5 times row 2, I'm going to write these numbers just down here, kind of in the background. So what is 5 times 0? That's 0. So I'm writing all of these right under here, actually, just as kind of a scratch work. So 5 times row 2 is 5. 5 times 9/7, I still have the 9/7 there, so I can just go 5 times and then press this answer button. Because answer is that 9/7, 45/7. Hopefully you can see that. It's a little dark. So 45/7. So these numbers that I drew in pink here would actually come in literally. They would sit here, right? Just like I literally brought in these -3 times row 1, right? I undid my 1 by doing that. You can always go back to the 1. So this is a way of saving time. So what I'm going to do is actually not change row 2, because I know that I could just multiply by 1/5 after this and undo what I did, thus kind of regaining the accomplishments we had from before. So what I'll do actually is now just add these numbers in pink up here to row 1. So 0 plus 1, good, still have our 1. 5 plus -5, that's our 0, good. 45/7, sorry, just to cover that. 45/7, and then I'm subtracting 4, right? I'm adding all these numbers. I'm adding up to row 1, creating that new row 1. So what I'm typing in now is just that answer, 45/7 minus 4. So 17/7. Right? And the nice thing about doing it this way is I don't actually have to change the row. I can kind of just use the imagined change, knowing that I can just undo that change anyways, and knowing that I always do want to undo that change. I just don't make the change in the first place, and I'll just write these numbers as scratch numbers, add those up, and then actually just keep that row unchanged. Right, if you look at what we did before, I multiplied by -1/3 to affect row 1 to make my 0. And that was cool, that worked. But ultimately, I wanted to go back to my 1 here. So I just undid it and said, all right, -1/3 times row 1, and that got me this row. Right, look at this row, and look at this row. And look at all the space in between there. Right, so there's all this work. Just kind of rehashing that. So you can just not change it and just use the scratch work approach. I'll go into more detail on that in another problem as well. So check out what we have. This goal is done. And this is our problem's way of saying x, right? If I go to the equation, x would be equal to 17/7. And y would be equal to 9/7. So you could write it this way, and we'll check this. Or you could write it as this ordered pair, 17/7, comma 9/7. I'm going to type this in using the calculator. Make sure we have a good solution. So up here, the claim is that these two numbers that we just found, I'm pointing at them off the screen, solve this equation. Right, so what I'm going to do is replace any occurrence of x with 17/7 and any occurrence of y with 9/7, and then make sure that I have true statements. Okay, so doing that. All right, so -17/7, right? I'm typing in my x there. And then plus 5 times 9/7, which is the y. What I'm hoping is that this is the number 4, and it is. Okay, so I now need to check the other equation with these numbers. If it's a true statement, then indeed this 17/7 and 9/7 is the solution. So I'll take 3 times 17/7 minus 9/7. And this should be equal to 6, which it is. So that's a good check. So yeah. These take practice. So if you're feeling kind of overwhelmed, yeah, I agree. It's all about what you do though now. Not you shouldn't feel bad about feeling overwhelmed. It's really about what we do now with that feeling that really matters. Okay, so here's a different one. And this is actually going to be the last one that I do in the video, because this one's going to take a little bit of time, and I don't want to fill up our whole day. So, this also is a system of linear equations, but we have this third unknown, the z component. So, what we want to do is take our augmented matrix. I'm going to write it down. Hopefully you can see where these numbers are coming from. I'll explain it in a moment. But I'm plucking off these coefficients. I'm noticing that all the variables are lined up, right? We want this to be the x column. So I wouldn't want to put like a mixture of x's and y's here. So -2. There's no y in this third one. So that's a 0, right? There's a 0 coefficient on the y term, essentially, which caused its disappearance. Then z gets a -1, and we have our 7. So what we want to do in this case is turn this augmented matrix through the allowed moves into our goal. But our goal is slightly different because we have a higher dimensional matrix. We'll have a 1, 0, 0, and then some number. We'll have a 0, 1, 0, and then perhaps some other number, and then a 0, 0, 1, and then some third number. This is actually the goal in this 3 unknown case. Hopefully you can see why, if this were the case and you rewrite the equations, you would just have x equals number 1, right? Nothing else, because 0 times y, that all disappears. Then this row is really speaking to y, right? So that second row is saying that y would equal number 2. This third row would be saying z equals number 3. So this would be our solution in this case, and that explains, why this is the goal, because really that just leaves our solution sitting there. So I'll write down this augmented matrix again, and then we'll go about this. Okay, so I'm not going to flip back and forth, but we do have those 3 allowed moves on the previous page. The first one talks about switching rows. So that's actually a useful move in this case. All right, this interchanging any 2 rows. That's actually a useful move. Check this out. Keep in mind, the first part of our goal is to make this 1. That's actually the first part of our goal. And then what we're going to do with that 1 is we're going to make the zeros below it. Then we're going to move to the second column. We're going to make the 1, and then we're going to make the zeros above and below it. Then we're going to move to the third column, making this 1 first, and then making the zeros off of it. So the first thing I want to do is change that 2 into a 1. And I can't just erase it and write a 1. That's not one of our row equivalent operations. So there are possibilities. One thing you could do is take 1/2 of row 1. right? If I want that 2 to be a 1, and I multiply that 2 by a half, I get my 1. There's nothing wrong about that. That's a completely legitimate move, and you can make that now if you want. The thing about it is it introduces fractions, right? I'll have half of 2 being 1, but then half of 1 is a half, and half of 3 is 3 halves. Half of 1 is a half again. So I'm introducing fractions if I were to do this, and let's just say I don't want to introduce fractions for now. Let's try to think of another kind of more efficient move. So interchanging rows. So if I switch row 1 with, this is my notation for this, row 2. Check out how I already get my 1 without much effort, right? 1, 2, 4, 6, 2, 1, 3, 1, -2, 0, -1, 7. That was interchanging row 1 with row 2. And just like that, just because I noticed, oh, there's a 1 sitting here, I can just switch this whole row with this whole row and I get my first part of the goal. So that's good. So now after you make that 1, you want to pivot off of it and make the zeros below. So let's see, I'll make this one a 0. I'm actually noticing that I don't even need to use the 1. I'm kind of noticing an easier step. What if I just, to make this 0, let's say I make this 0 first, which actually doesn't matter. I could just take row 2 plus row 3, and that can equal new row 3. Right? Since we have a 2 and a -2, that'll give me my 0. So I'll actually just do that, just to show you that you have creative license here. You know, if you notice something that's nice and accomplishes good things, go for it. So I'm just writing down the other 2 rows. And now I'm actually adding row 2 to row 3, and that's creating a new row 3. So 2 plus -2, that's a 0. And that's the reason why I'm doing this, because that accomplishes that 0. 1 plus 0 is 1. 3 plus -1 is 2. 1 plus 7 is 8. So I actually just, in this particular case, made this 0 first. I just still need to make that 0 above it. For that 0 above it, I am going to use the 1. So notice we have a 1, we have a 2. If this were a -2 and then I added it here, then I would get my 0. So I'm going to make that happen. -2 row 1 plus row 2 equals new row 2. What I'm going to do is what I suggested earlier. I'm going to actually just write these as scratch work. So -2 times 1, -2. -2 times 2, -4. -2 times 4, -8. -2 times 6, -12. These numbers in pink are actually the ones I'm going to add down to row 2. So I'm going to add these here. So doing that. So I have 1, 2, 4, 6, right? Row 1 is not changing, but row 2 is. So now I'm adding -2 down to 2. I get my 0. -4 adding down to 1, -3. -8 plus 3, -5. -12 plus 1, -11. And then row 3 is just hanging out. So I'll just write it down. Okay. Looking at where we're at, column 1 is done. So column 1 is done. What I'm now going to do is move to column 2, but the first thing you always do in a new column is make the 1. Okay, so I'm first actually going to focus kind of in this location, knowing that I want that to be a 1. Okay, so I could, if I just want this to be a 1, I could multiply row 2 by -1/3. You see how that accomplishes that? This is still going to be a 0. And then negative 1/3 times negative 3 would be that positive 1. This would absolutely work. It is completely legitimate. It's correct. The thing about it is it's not the most efficient way again, because you'd be introducing fractions. And let's just say we don't want to do that for now. Sometimes you can avoid that, but sometimes you can. So how do I make this a 1? I want this still to be a 0, right? I don't want to mess anything up, but I just want a 1 here. So check out the 1 right here. So if I switch these two rows, so if I say row 2 switched with row 3, that actually is a nice efficient way of creating that 1 where I want it. So 1, 2, 4, 6, I'm just writing down the first row again. And then actually switching these other rows. So I'll have 0, 1, 2, 8. That is now my second row. And the old second row is now my new third row. So that actually is a nice way of getting this 1 figured out. Now what you do is you need to make the zeros above and below it. So we're working again column to column. So I need to accomplish the first column, and then I move to the second one. Then after getting everything done in the second column, then I move to the third column. So now that I have this 1, I want to make zeros here and here. Let's first make this a 0, okay? So one way of doing this is 3 times row 2 plus row 3 equals new row 3. Again, to save a little time, I'm going to just write this imaginary kind of row 2. So I'll still have a 0. 3 times row 2, so 3 times 0 is still 0. So I'm writing that product here. 3 times 1, 3. And kind of lost my place, which is totally possible. 3 times row 2. So I have a 6 now. 3 times row 2, I have a 24. So again, that's why I recommend kind of this notation. I started thinking about something else, and then I kind of forgot where I was, but then this helped me remember. So now what I do is I add down. So I'm now adding these numbers in pink down here to the third row. So I'll just write down the other 2 rows. They're not changing yet. All right, it's only row 3 that is being changed. So now the actual adding. So nice that when I add the 0 to the 0, I don't affect that, right? I still want my zeros. So 0, still there. 3 plus negative 3 is now that new 0, which is good. 6 plus negative 5, 1. And 24 minus 11, or plus negative 11, however you want to think about it, 13. So I actually accomplished that one. I did notice that the 1 appeared, but that was kind of accidental, so I'm not going to kind of check that off the board, right? Because it might change. So now that I have this 0, I'm going to make this 0. Again, still using this 1 to make this a 0. So one way of doing that would be negative 2 row 2 plus row 1 equals new row 1. So I'm going to be multiplying row 2. So negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times 2, negative 4. Negative 2 times 8, negative 16. And now these numbers are going to be added up to row 1. So 0 plus the 1 doesn't mess up our 1. That's good. Negative 2 plus 2, 0. Negative 4 plus 4, actually 0 also. Negative 16 plus 6, negative 10. And nothing else changed, right? That was just the row that changed. It was new row 1. 0, 1, 2, 8, 0, 0, 1, 13. So yeah, column 2, right, is completely done. And now what I want to do is move to column 3, first creating this one, right? That's been the pattern, is every time we move to a new column, we create the 1 in that column first. So luckily, yeah, we do want that 1, and that's already done. So that is there, and now I will just say, yeah, we're actually good on that. And now I'm going to make the zeros above it. So actually, this 0 is already made. So we got lucky, kind of doubly lucky, I guess. So the only thing I need to do now is turn this 2 into a 0. So one way of doing that would be negative 2 row 3 plus row 2 equals new row 2. And again, just to make my scratch work kind of notes, the negative 2 times row 3, I'll write that result here. So 0, 0, negative 2 times 0, 0. Negative 2 times 1, negative 2, negative 2 times 13, negative 26. So I'll add these numbers up. Write those here. So the first row is done. It looks like x is going to be negative 10, right? But we'll get there in a second. And then adding up. So 0 plus 0, 0. Right? I'm adding all these to row 2. 0 plus 1, 1, good. Negative 2 plus 2, 0. Negative 26 plus 8, I believe is negative, oh gosh, my arithmetic. Negative 18, yeah, that's not what I was thinking. And then finally this last row here. So 0, 0, 1, and 13. This is now the final goal, right? Everything is met. So this is the matrix way of saying x equals negative 10, y equals negative 18, and z equals 13. Or you could write that as an ordered triple. Negative 10, negative 18, and 13, like that. Just getting the order right, x, y, z. And let's go ahead and check this. I know it's been a long video already, but yeah, you can check these. So, typing this in, I'm now going to attempt to do that. So I'm typing all these in, making sure I get true statements in each. So 2 times negative 10 plus negative 18 plus 3 times 13, okay? So if you didn't catch all that, I'm plugging in our xyz into the first equation to see if we do indeed get a 1 on this left-hand side, and we do. What you can do is just go back and change your coefficients rather than changing your potential solution. So the second equation has a 1. So I'll do 1 times negative 10, or you could just delete the 1, right? Negative 10 plus 2 times y. So I'll just bring in a 2 times here, because y is still negative 18. So I'm just editing. 4 times 13, right? This should be a 6, and it is. Okay, I'll just start over. So negative 2 times our x is negative 10 plus 0y, so I'll just not write anything. So minus z, so minus 13. This should be 7, and it is. So this would be a good solution here for this system. Talk to you all next time. Bye-bye.